Hello everyone, and welcome to Giving REST a Rest, an introduction to GraphQL. My name is Gary Parker. I am a solutions architect with Liberty Mutual Insurance, and I've been working with GraphQL in production for about 2 years now, at a pretty reasonable scale. And so, looks like I might have lost internet. No, cool, we're good. All right. So just to clarify too, I said I know the title was Giving REST a Rest. I don't mean that REST is dead. There's still a lot of use cases for REST, especially in microservice architecture, and, communication within a data center where latency might not be too bad of an issue. REST brings a lot of positives, especially when it comes to being able to see into requests at the network layer. But I think that we've grown now to a point where we have some use cases where REST doesn't always fill what we need. But if we try to make it do what we need, we kind of start implementing some anti-patterns. So my goals today are to provide an introduction to GraphQL, kind of describe the deficiencies in REST, where especially from a performance standpoint, GraphQL might provide some opportunities, and still understanding of the benefits, performance, scalability, developer experience, really important. And finally, demonstrate just how easy it is to implement GraphQL. So what is GraphQL? So GraphQL is a query language for your API. When people first hear it, they think SQL, they think database communication, nothing to do with each other. An easy litmus test is if you would ask a question about GraphQL, think if you would ask that about REST. If the answer is no, it probably doesn't have to do with GraphQL. So while REST provides things for, mechanisms for talking about authentication or authorization, it's not really concerned about those things. And likewise, GraphQL is really not. It's about optimizing the communication from your client to your API. Oops, I skipped something. Nope. So GraphQL is also a strongly typed language. That means clients can get exactly what they ask for. Again, super important for performance. You're only getting the fields that you ask for. You're only getting the objects that you're asking for. And the client is really dictating the needs from the server. For those that aren't familiar, GraphQL was developed by Facebook right around the same time as React. They actually kind of came up together. And it's used at companies like GitHub, Netflix, Yelp, Intuit. It's being used by a lot of big companies. Even companies that, like Netflix, actually had kind of their own alternative implementation trying to solve the same challenges are now starting to adopt GraphQL. So what's wrong with REST? We've been using it for a while now, right? It's a lot better than SOAP. Well, there's a couple of challenges that come with REST. REST is really about being resource focused. Which is great, but it means that you probably have to do multiple requests to get all of the data that you need. That in a true REST API, your resource for things that it's related to is really just pointing at another endpoint to go fetch that data. And clients typically have no way of we call that underfetching, where we have to do multiple network requests just to get the data that we need. And then the other part of that is there's no way for a client to tell it just what it needs. So if you query a user endpoint and all you need is first name, last name, you might get back this huge user object, much larger payload. You're just adding overhead, and we call that overfetching. So here's an example of underfetching. I hope you guys can kind of see this. It's washed out a little bit with the projector. But this is kind of a typical kind of REST API where maybe we want to get some information about a book. We want to see the author, maybe see the other books that they've written. And if we want to go down that path, we start off with, well, okay, so we know this book. We'll get some information about it. We'll get some information about the author by virtue of making another request. Oh, look, we have more books. We can go make other requests. And this is kind of an extreme example. Sometimes some of this data is built into your API a little bit. This is really not too far from most use cases. And if you find yourself creating custom APIs to start solving these challenges, that's really just an anti-pattern, and you're just asking for challenges as you scale, as you have different clients asking for slightly tweaked versions of the same kind of data. Are you putting in query parameters to try to solve this? Are you making custom endpoints for every iteration on your data? It's just not a great way to solve this challenge. And getting back to the other challenge, overfetching again. If we were just looking for some books that the user read, we're getting a lot more data back potentially. than what we really need. There's no way with REST for a client to dictate its needs to the server. So enter GraphQL. So before I show an example of a GraphQL query, just kind of give you guys an introduction to the schema, kind of what it looks like, how you work with it. GraphQL has scalar types. It's kind of tough to read, but at the top we have int, float, string, boolean, ID. Probably pretty common things to everyone in this room. IDs are just globally unique strings, essentially. We have type definitions, so scalar types, like I just mentioned, types which are objects, interfaces, very similar to classic object-oriented programming, where you can define the shape of an interface and then have different types implemented. There's an example right here. See, we have unions. Unions can be really powerful for when we have a couple different types that the client can be asking for. So in this example, we have just kind of a generic search query that can return either an artist or an album. And I don't have an example of this, but what the client can even do is say, well, based on whether it's an artist or an album, I can ask for different fields. So if it's an artist, I can get the name of the artist, or maybe the group members. With an album, I can get some different fields. We also have enum types. If you're familiar with enums in programming, same principle. Just a list of accepted kind of values. And we have an input object type, which is just very similar to a regular object type, except for it's only scalar values. And we just use that at the time of input for queries. We can also denote that types are required with an exclamation mark. And we have lists, which are denoted with square brackets. All right. So how do we define our types within GraphQL? Types really are the heart of GraphQL. So this is a very simple schema that tries to solve that same challenge that we saw before with those REST endpoints. So what we have here at the root is this query type. GraphQL has 3 different types that exist at the root. That are kind of special and unique. We have query, mutation, and subscription. Query is just for getting data. You can think of it as like a get in REST. Mutation is for anything with side effects. In REST, it's traditionally done with post, put, patch. And we also have, not shown here and probably not touched on too much today, is subscription. And that's for doing kind of WebSocket data over time queries. So back to our example. So we have a user type that has an ID, first name, last name, favorite book. You know that the favorite book here is a book type, which is defined over there. We have books that they've read, which is a list of, again, books. We have registration date, which is just a string, a last login, which is just a string. We have our book type, again, ID, author, author type. A title, which is a string, a publication date, which is just a string, and we have our author type, which has an ID, first name, last name, and the books that they've written. And so with everything that I have right here, I can describe almost infinite kind of permutations of different queries that the client might ask for just by having the schema and having those relationships well defined. One note too on the scalar values, you can actually create your own too. So like I have date here as a string. If you wanted to create your own scalar value for date, you can actually do that as part of the spec. So, okay, so we had those relationships. We defined those in the previous slide. How do we actually get the data? How do we tell it about how they relate to each other? So, and this example is done with Node on the server side. When I walk you guys through today, it'll be Node JavaScript code, but there's frameworks and libraries and things for pretty much every other language, whether it's Ruby, PHP, even Haskell has a library. So pick your backend and this will still work. But essentially what we're doing here is we're creating a map for telling GraphQL how to resolve data for these different types. So again, I mentioned that root query, that's the important part. That's kind of how we get into our graph. So that query has a user property which can take arguments, and it looks like it's expecting the arguments of an ID. We have a user type that we saw on the previous slide, and we can do some things where we actually tell it how to resolve data for individual fields on a type. So what you're not seeing here in this user field is how I resolve all the different types, only the ones that maybe don't get fulfilled by that get user function. And so I need to be able to tell it how to get the books that are associated with maybe array. Oops. an array of book IDs. We also have a type for the book itself. Again, filling in a field that the parent object doesn't know about, getting the author. We're doing the same on the author with getBooks. I'm going to get more detailed into this in a little bit as I go through like a live code exercise. And so what we end up with just that code that you saw right there, and just that schema, and that's pretty much all it takes, is we end up with a backend to support a query like this, where now I'm asking for the suggested books. I'm passing a user ID to that user query that we added both to our schema and in a resolver map in the previous slide. And now I can ask for first name, last name, maybe their favorite book, the author of that favorite book, the books that that author wrote, and the titles of those books. And this is what I get back. This is actually the JSON that's returned by the server, and that's exactly what I asked for. Nothing more, nothing less. I can change this around. I don't have to make any changes on the server. I can keep going n levels deep if we kind of have some relationships kind of point at each other. And it's really, really powerful. I'm going to pause right there. Any questions? All right. As I'm going, please let me know if you have questions, especially on syntax. I know not everyone here does a lot with Node.js, but again, all this translates to other languages, so please just fire away. All right, so from here, I'm going to take it to, and I'm going to be a little bit brave because it's going to be a live coding exercise. Don't judge too harshly. But I have basically the shell of an application. The idea with this application is it pairs users with teams. They can come together, make teams, and those teams can work with charities. So charities have some skill sets that they're looking for. Users have skill sets. And the idea behind it is that maybe we try to create something where people could kind of come together as a group to volunteer with a charity. But let's dive into the code. All right. So I have in place just a couple imports in each of these files, just to kind of give me a clue as to what I need to do in each one, frankly, but also just to cut down some coding time. But I'll just try to explain everything I'm doing here as I go along. So this is really a pretty basic Node.js app. All of our business logic is contained within modules. So we have one for module, team, or charity team, user. Nothing in here is directly related to GraphQL. I'm just kind of pointing these out. And to mention that I'm going to be stealing the structure kind of from our schema to kind of be represented in our graph. It doesn't have to match. We can change fields around as we're resolving data, no problem at all. In fact, that's often considered a best practice with GraphQL. You don't have to make your the data that's exposed to your front end match what it looks like at rest. You're much better off to have your data represent the needs of the client. This is a general GraphQL best practice. So stepping back. So starting at line 1, so this is the entry point for our server. You see I'm importing Apollo server. So Apollo is a company that provides a lot of library and tooling around GraphQL. They make some really great tools, especially on the client side. It makes it a lot easier to get up and going. The Apollo server takes care of the web server implementation itself, but if you're working inside of an existing Node.js framework like Happy or Express, there's hooks for tying directly into those. All right, so the first thing we're going to do is create a server, which is a new instance of Apollo server. And that takes in the constructor, it takes a configuration object that we're going to fill in, and then we're just going to start this up. So server.listen, and that's a promise, so we're going to then it. That's going to return a function. That object actually has a URL property, and we're just going to console log. Oops, that's not what I want to do. All right, so this is probably going to complain to me. Cool. So the reason why it's complaining is because this Apollo server expects a schema. It needs a schema, because otherwise it doesn't know anything about us. So let's make a schema. So I have the schema file. The only thing I've done so far is import GQL from Apollo server. GQL is also its own NPM package. You can install it independently. And it's really just a function for taking a template literal, which is going to include our schema, and then translating that into GraphQL. So if you were to do like const type defs equals GQL template literal string, and we could just export this. Oops, wrong syntax. All right, so now we can write that schema that we saw on that other slide. But we're going to change it around a little bit because now we have a different domain. We're going to come up with our own schema. So the first thing we need is a query. All right, and so let's see. So let's expose a. We'll start small. Let's do a hello world. I don't know if you guys have ever seen hello world before. We'll try something new. All right, so we have hello. It's a property of query, and we'll have it return a string. So if I save this now, let's see, how's our server doing? It's probably going to crash again. What doesn't it like? Oh, I forgot to import it, or add it to our constructor. All right, so now we actually have some type definitions to provide, so now I think it'll be fine. Cool, so it started up. So let's see what we got. What does the server give us? So this is GraphQL Playground. So this isn't GraphQL itself, but this is a client that we can run in the browser that Apollo server provides us. We can also run GraphQL Playground independent of having our own server. We could take this tool, point it at a remote API, and use it to interact with that GraphQL API. There's also an Electron app version of this as well. And what it does is it allows us to write GraphQL queries. And it does some really nice things. You saw that autocomplete there. So if I were to say hello, it says no, because we haven't told GraphQL yet how to say world back. We'll do that in just a second. And it also shows their schema as well. So we can dig through, and as we add types, you'll actually be able to go and browse into those types, see all the different fields, what's required, what's not. And you get that for free with GraphQL via introspection queries that it allows. So let's make it say world real quick, and then we'll do something more interesting. All right, so resolvers. I talked about this in the previous slide where we have this mapping of functions that map directly to our schema for telling GraphQL how to resolve data. So if we were to define let's see, an object, and it needs a query property, and that query property needs a hello, right? And that's going to be a function, and we'll make it return world. And let's see. Oops, I probably should export that. And now we have to add it back into here. All right. As you make changes, you're going to have to reload. If you make changes to the schema, you're going to have to reload GraphQL Playground just to get that nice like autocomplete. But now we have hello world. So we've told GraphQL, so far what we've done is we've added a field to our query object, and we've told GraphQL how to resolve it. That's great, but it probably maybe a little bit more helpful if you saw it actually with like some real data and start to do some real things and start writing your own queries. So let's do that. All right, so let's fill out the schema first. Let's ignore that for now. All right, and I got a good idea too. Can everyone see this from the back, by the way? Cool. All right. So I'm going to make the user type, and just to make sure that it aligns with what I have over here, I can do this. And let's see. So I'll do ID since we want everything to have an ID. And let's see. How about let's see. So users have names. That's a string. They have skills, which is an array of strings, and they have team IDs. But you know what? I don't think team IDs is too helpful, really. I think I'd rather have users have teams So I'm just going to say they have teams. Well, that means I got to define a team. And we'll do this. And I make this required too. So those are now required, as we saw from before. So teams have a name, it's a string. They have info, which is a string. They have location, it's a string. They have member IDs. Again, teams have users, they don't have member IDs. So let's just add members. And that's an array of users. User. And charities. Oh, again, charity IDs, not charities. It's charity. Yeah. All right, so now we have to define a charity type real quick. And charities have a name, which is a string. And they have needs, oops, which is an array of strings. All right. So that gives us type, but it doesn't give us a way of kind of asking GraphQL for those types. So what we need to do now is kind of start exposing those types via properties of our query. So if we were to say, let's get the list of users. So users, let's make it take as an argument IDs. And that should be an array of IDs. And it's going to return a user. All right, so real quick, I'll just kind of go over the syntax of that. So, oh man, everyone able to see this? Ah, sorry.
Not really.
I'm sorry. Let's see, I don't know if I can. It makes it worse.
Is the code anywhere available to just go and scan through?
Not right now. I can post it like GitHub afterwards.
Okay, thanks.
I apologize. I'll try to talk through it. I know. Sorry, the display in here is really rough. So what's going on now is I've added a user's query to my query type. I'm sorry, a user's field. It takes as arguments IDs. That's an optional argument. And it's a list of ID, and the idea back, and it's going to return users, right? Not a user. All right, so I think that's our schema, so that now if I were to actually go and talk to GraphQL, it knows about these different types. It doesn't know how to resolve them yet because I haven't added kind of matching attributes to our resolver map, but at least knows about these types, knows how they're connected, and knows what they should return every single time because this is strongly typed. Let's see, so if we go back to our resolvers, so let's see, we called it users, and let's see. So the signature for a resolver for a function that's going to resolve data, the first argument is actually a reference to the parent object. In this case, it's the query object, which doesn't really provide us much information. And then the second argument is the arguments that are passed to that field. So if we were to call this args, and we were to call, let's see, so we need to get users. If I were to pass args dot, let's see, IDs, is that what we called it? I think that's what we called it in our schema. Yeah, IDs. That should now take those user IDs that we are passing in our query. It should call the getUsers method, which goes into our users model and is going to retrieve that data from the database if everything I did is right. All right. So that's a good sign. And we have to provide it with some attributes to get. So let's see. Cool. It worked. So I had in my database already a list of users with some data already there. But you can see how quickly I went from having pretty much zero GraphQL in my application to now being able to support a single query. But I think where it starts to get really interesting is where you start defining those relationships. So right now, if I were to ask for teams, and I were to ask for team name, I'm probably going to get null. Because it doesn't know anything about teams, right? We saw when we looked at the model that the user has team IDs, but team IDs aren't teams. So we need to figure out a way to kind of tell it how to go from that list of IDs to a list of objects that match our team type. So let's do that. So just like we're resolving our query, we can also resolve types. So if I were to try to resolve a user type, and I need to resolve team. If anyone's not familiar with the syntax, so this is these are just arrow functions in JavaScript. It's the same as doing a function, and the expression on the right-hand side of the arrow is just automatically returned, unless you have curly brackets around it. So here's where things can get a little interesting too. So now, I mentioned before that this first argument is actually a reference to the parent. So with team, the first argument is a reference to the user. So if we were to say that this is a user, well, we know already that a user has some properties, including team IDs. So we can actually take that and call getTeams and pass it user.teamIDs. And in theory, oh, they didn't like something there. Oh, it's not in my schema. I gotta put in my schema. The errors are helpful too. So if I go back, let's see. So did I call it team or teams in here? That's probably what I did. So teams, did I call it team in here? Yeah, teams. There we go. Cool. All right. So if I were to rerun that query, now it knows about those relationships. And so now I can go and do this. So teams, oops, if I can type, have members. Those members have names, and those members have teams. Those teams have names. Do we think this is going to work? No, but close. So we forgot to tell, just like we had to tell GraphQL about users having teams, we have to tell it about how the teams have members. Then I think it'll work. So same deal with the user. Did I do that right? No, it's on the team. So like I said, teams have members. We have access to that team object. We can do get users, and we can pass a team.member. What do we call this? If I go to the team model, member IDs. All right, now let's try running our query. Boom. And so without having to come up with an endpoint that was, let's see, a list of users with their teams, with their members, and those teams' members, I now have all of that data, a single network request, really fast, only the data I'm asking for, strongly typed, and that took me about 15 minutes. So that's pretty fast. And I think the really powerful thing about it too is that we can start implementing this in existing applications, especially if you have really clear separation between your API layer and your business logic. It becomes really easy to do what I just did, where we just start exposing this data, incrementally via GraphQL, and it allows you to write some really powerful queries. So let's see, we have till 3, right? All right, so how about this? I could keep going here. I think I might have to fill in a couple things, but it might be helpful to show from a client's perspective kind of how the client implementation works and what that looks like. So the example I have for everyone today is in React, but again, it doesn't have to be, it doesn't even have to be a single page application. There's a lot of mobile apps using GraphQL with different technologies. But just to show you kind of how easy it is for a client to kind of ask for that data and how quickly you can get that going. The React code's already written. I wasn't sure how much time I'd have to run through it, but since it's so implementation specific anyways, I think it's probably just better if I just show you kind of guys. Oops. So I'll fire this up and start showing, I'll show code first. So implementing in React, there's only a couple of things we really have to do. The first of which is just create a client. So I'm using Apollo Boost here. It's bad. To create our GraphQL client, all I have to do is tell it the URI or URL where it's actually going to go and talk to that API. So right now I have a relative URI at /GraphQL, and it's just that one endpoint to get all of its data. So I create an instance of my client. Let's see. I provide that throughout my app, so this is kind of a React-specific thing where I use an Apollo provider, which is, again, specific to React. It allows it via context to kind of go through my application. Anytime within my client, I can then go and pull out that client, essentially is how it works, and get access to it. So in React, we have a design pattern called containers, where we have these things that are responsible for getting data, essentially. And I can write a query right in here to get the list of team members. GraphQL natively has variables. You can kind of see the variable substitution up at the top there where I have that $team ID. That variable is going to get substituted in. So this is just like we were writing in GraphQL Playground. I wrote a GraphQL query. It's going to ask for the team. It's going to be able to pass it the team ID. It's going to ask for the members on that team, their name, and their skills. And so this is the query. This is how we actually execute it. There's different ways to do this as well. This is Apollo's recommended way of executing a query. I'm not a huge fan of it, if I'm honest, but it is highly declarative. I'll give it that. But essentially what we have here is a query component that's going to take that query defined up above as an argument. It's going to take the variables as an argument, and it's going to give us, and it expects as a child, a function that has, that when executed, it's going to provide as an object data, an object with a data, loading, and error properties. And we can use those properties to figure out where in the life cycle that request is. So if it's loading, I could just have it display like a loading indicator. This could be a separate component that it goes out and renders. If there's an error, I can render an error component. And if I get the data back, I can show the data. It also has the option for refetch, which I'm not using here. But if you wanted to refetch the data, expose that as a button, do polling, whatever you want to do, you can do that as well. Let's see. Nope. Yeah, it's loading. Anyways, so while that's coming up, any questions on like the client implementation? This is all, again, very specific to React, and even specific to kind of how Apollo does it. But if you're using other state management tools, if you're using MobX, Redux, anything else, those still work just fine. You can call it independent of these client libraries, but they do provide a lot of value for managing your cache, hooks for kind of manipulating the GraphQL hook. They call it operation, which is the request response. It's a lot of powerful tooling around it. I got an error. And I suspect what probably happened is I think the shape of my API. Oh, did I stop the API? No. Huh. All right. I'm going to cheat. Because there's only a couple minutes that I can cheat. I suspect I probably left something out in the API. Or I broke something in the client. Cool. And so here's the data exposed via our API. I can click on it, get an error, but also get the data back too. So like this is actually going through that GraphQL server, getting that data, minimizing our network requests so it's really, really fast, really powerful. It provides a lot of flexibility to our API. We can do a lot of interesting things. Our API is allowed to kind of grow over time. One of the challenges with REST is usually it's highly versioned and you want to be very careful about making changes. But with GraphQL, it actually has built into it tools for like deprecating fields. So we can tell clients that this field that they're using is deprecated. And not only that, because we know what they're asking for a field, we can actually see when it's in use. We can see which client is even using it. We can log that. And then if we go, hey, look, nobody's using this deprecated field anymore, we can just safely remove it. And so it's really powerful that you kind of have this API that can grow over time. We can add new fields, and people that have an existing query, they don't all of a sudden get more data than they were expecting. We're not breaking things potentially just by adding new fields. So it's really powerful for growing your API over time. And I think we've just got time for a few questions. Anyone? Sure.
I have a non-developer question.
Yeah.
Are there any like high-level reasons that it would make sense to stay with REST?
The number is shrinking. So like one of the, like I mentioned at the start, and I had that first slide that was like, does not mean REST is dead. I'd caveat that, but so like one of the places I said earlier was microservice architecture, where we have a lot of small decoupled services that don't really need to know much about each other, maybe inside of like a database or within an AWS region or something like that, where they talk to each other low latency. We can make a lot of requests and there's not a lot of overhead. REST still really makes sense in that architecture. However, there's been a lot of work on what they call like remote schema stitching, where you can actually peel together like all of these remote pieces of your schema and expose that, and still have microservices, but speaking GraphQL.
How is
Authentication?
Yes.
I was waiting for somebody to ask that. Yeah, perfect. So there's two things that aren't shown here, right? Authentication or authorization. So the first part, you can handle authentication pretty commonly like how you do like a normal web application right now. So like you could have a mutation that takes a username and password, and that could return a token like a JWT or a cookie to the user, and then they would use that on subsequent requests, right, to protected resources. Authentication, we can handle it in a fairly elegant way. So one of the things I didn't show here is this thing called context. Oops. And I can actually probably write the code. Let's see. So we can actually define this thing called context. That is a function that takes, I think it's an object with a request. I think that's the signature. I'm just going to kind of fudge it a little bit. And we can add that to our server. And now we get a new context every single time a request comes in. And so what we can do here is we can look at that request object. We can pull the authorization header off of the request. If it's like a JWT token, we can validate it, pull like the user ID off it, things like that. If it's in a session, go get that information. And now we know for the remainder of that request who you are. And then if we go back to our resolve mapper, let's see, where did it go? Here. So there's actually a third argument we can add here that's context. We can actually pass that to our business logic layer. So we could do like context.user ID, something like that. And there's authorization, which I would argue belongs at that business logic layer. Yep. Great question.
For someone new getting into this, what are the best like debugging tools to use, or
Yeah.
at least the playground? But
Yeah, GraphQL Playground is awesome. Starting to get familiar with like writing the queries is really the big part. There's a lot of open GraphQL APIs that you can play with. GitHub has one. There's a very famous Star Wars one, which is great because there's just like anything you can imagine Star Wars is in this GraphQL API, and it's a lot of fun to play with. So there's a lot of resources out there. Apollo, the company kind of behind those libraries that I showed, they've done a ton of documentation, examples, kind of started to feel out best practices. Any other questions?
is Apollo really tied to GraphQL, or is the Apollo client also can be used for REST?
They're trying to grow it beyond GraphQL, I would say, because typically in single-page applications you have this challenge of maintaining state, which is kind of like maintaining the things as things change. And they're trying to get into the state maintenance part of things as well, because they already do that for data. And so they're trying to create the APIs to do it on the UI side as well, so like managing UI state. I think they want to get into that, but they're primarily focused around GraphQL. Anything else?
You mentioned that it's a best practice that you don't need your back-end representation of your data and what you're exposing through GraphQL
Yep.
to be the same. And I can see that with the resolvers because you could easily say, oh, it's called a team, but actually go and fetch these 3 different objects and stitch them together
Yep.
for whatever reason.
Sure.
And I guess I was just curious about where the real benefits are. Like, why is that a best practice to keep them separate?
I think it's about separation of concerns, honestly, and especially like if you think of your API, especially if you think of your API as not just for you. I think that's where it really starts to make sense. Like I can only imagine what GitHub has under the hood to be able to provide the fields that they're providing to me, but I don't want to know about that, right? Like I want to know like list of repos and things like that. I don't, all that other stuff underneath that. I probably don't care as someone who's consuming their API, and I think it's just kind of a general best practice with APIs, anyways. Is write it like there's 100 other people that are going to be using this, or 1,000 other clients that are going to be consuming this, and it really makes you be more thoughtful and careful with how you write it, how you change it, and how you evolve it. Anything else? Awesome. All right. Thank you, everyone.
Great.